Hello, good morning and welcome to this class. In today's tutorial video, we shall be solving this problem before us. This is a Kirchhoff's law problem, and this was the last problem I gave, and I asked you guys to solve and put the answer in the comment section. So today we shall be finding I2. If you notice in this sequence, you have I, which is the current passing through this side, I1 current passing through this side, and I2 current that flows through this side. So we shall be finding a I2, okay, and we shall know if power is being dissipated by this resistor using Ohm's law and Kirchhoff's law. Now if you look at this, we have two loops. Let us label them. This is A, B, C, D, E, and F. So B, C, E, F is a loop, and A, B, E, D is what? A loop. So this is a problem on Kirchhoff's law. Of course, you see that we have more than one source of EMF. Using Ohm's law alone cannot help us find I2. So we shall make use of Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law states that the sum of currents in a circuit equals 0. That is the sum of the currents that flows in a circuit that should equal 0. Or the sum of the current that enters into a junction equals the sum that leaves. The sum of the current that enters into a junction equals the sum that leaves. If you notice here, this is a junction. This is a junction. And this is what? A junction. A junction is a place where three or more wires meet. Is a place where three or more wires meet. So if we take this as a junction, the current that is entering this junction is I. The current that enters the junction is I. And the current that leaves the junction is I1 plus what? This is I1 is leaving this junction plus I2. So these are the currents leaving this junction. So in this problem, we shall make use of simultaneous equation method to find I2. Alright, let's get started. If you have not watched our introductory video on this, you can go back to our playlist to find them and watch. So in resolving this, we can choose to go clockwise or anti-clockwise. So this is clockwise motion. This is clockwise. What you do here, you do there. So we shall make use of this clockwise motion to find I2, which is the current that flows through this resistor. We shall know if actually current flows through this resistor or not. So let us start from this junction and take our movement. So if we start from here, let us start with this loop first, or we can choose to start from any of the loops. It doesn't matter. If we choose to start from this loop, taking from this junction, we start moving. This is the positive side of the cell to the negative. We are moving downhill, so the EMF there is negative. I have minus 6. We keep on moving. This current is in the same direction with our movement, so we have a voltage drop across this resistor. You have minus 1 I2, so we can just say minus I2 because this is just 1. We are doing this from Ohm's law. V equals what? IR. So for the source of EMF, the unit is in volts, so we just write 6. For this, to find the voltage drop, we use the V equals IR, where the current there is I2. The current is I2 and the resistance is 1. So 1 times I2 is just I2. You keep on moving. This current pass through this side. So when we reach this side, you notice that I1, you notice that this I is passing through this. So, and it's still in the same direction with our movement. So you have a voltage drop here. they have minus 6i, minus 6i. We keep on moving. We meet a source of EMF. We are moving from the negative side of the cell to the positive. So you have a voltage lift. So the EMF there becomes positive. Plus 10 equals what? Okay, we are not yet done with our movement. Look at this. This is a resistor, and our movement is in line with this current. So you have a voltage drop there. You have minus 2i1. So this is minus 2i. The current that flows through this is I, not i1. So you have to take note of the current flowing in the paths when you are resolving. So you have, this is I equals what? 0. And some persons will ask, why are we taking this? We are taking this from Kirchhoff's voltage law. It states that the sum of the EMF and the potential drop across the circuit elements, that it should equal 0. For this case, this is EMF. For this is potential drop. So everything should equal 0. And once you are you do this for a loop, you do the other one for the second loop. So in this problem, we have solved for 2 loops, and I have said we are going to make the simultaneous equation method to find I2. So this is just for 2 loops. Subsequently, I shall be solving problem involving 3 loops. So if this explanation you didn't get it clearly, you can go back to our playlist to watch the introductory video, and don't forget to subscribe for more updates. If you want to see updates on videos like this, you don't forget to click the subscribe button below. So let's keep on going. So for us to resolve for the second loop, we still take this direction. So this is, we start moving. This is the positive side of the cell to the negative. So you have the EMF there becomes negative. So you have minus 4. Keep on moving. You meet a source of this is the resistor, and the current is in the same direction with our movement. So you have, from Ohm's law, you have minus 4. The current that flows in the path is I1, minus 4 I1. You keep on going. So if you meet this part, this is another part. You notice that this is the direction of our movement, and this current is opposing it, is moving against it. So you have a voltage. From our sign conventions, we have a sign convention in which we are following, and if you have watched our introductory video, this becomes very clear. So you have a potential lift here. So since this is 1, just 1, I'll just write plus I2. This is I. Okay, this is I2, not 1. I2. All right, let's keep going. We meet a source of EMF. In this case now, we are moving from negative side of the cell to the positive. So you have a potential a voltage lift. So of course the EMF here becomes positive because we are moving up here. This is plus 6. So we have completed the movement. This is the junction. We started from here and we ended here. Here we started from here and we ended here. So we have completed the movement. We say equals what? 0. So let's call this equation 1 and call this what? Equation 2. We can now solve this simultaneously. So solving this simultaneously, we have, if you notice, this is I. This is I2, this is I1, and this is I2. We can't go ahead to solve this simultaneously unless or until we make this and this to be the same. So we should be looking for I1 here, so that if you have I1, I2, I2 here, we can solve them simultaneously. So from Kirchhoff's current law, we know that I entered the junction and I1 and I2 left the junction. So from this now, from equation 1, we have that minus 6 minus I2 minus, this is minus 6 minus 2 is minus 8I plus 10 equals 0. I am rewriting equation 1. So this is minus 4I1 plus I2 plus 6 equals what? 0. Equation 2. So if we replace I equals I1 plus I2 in, substitute I equals I1 plus I2 in equation 1. So what are we having? We have minus 6 minus I2 minus 8 brackets I1 plus I2 plus 10 equals what? 0. This is equation 1. So we keep on going. We clear the bracket. Minus 6 minus I2 minus 8I1 minus 8I2 plus 10 equals what? 0. This is still our equation 1. So collecting like terms, we have minus 6 minus 8I1 minus 9, this is 1 and this is 8 here, minus 9I2 plus 10 equals 0. This is equation what? 1. So we can now say, this is for equation 1, we can now say minus 6 minus 8I1, or we can decide to write it in terms of I1 first. So if we write it in terms of I1 first, we have, if we write this equation 1 in terms of I1 first, we have minus 8I1 minus 9I2 minus 6 plus 10 is, this is plus, is 4. See, plus 4 equals 0. This is our equation 1. We can now call our equation 2, which is here. This is our equation 1 and this is our what? Equation 2. So let us see, write it in terms of I1 first. We have minus 4I1 plus I2. In this case, minus 4 plus 6. This is plus. We have 2 here equals 0. This is our what? Equation 2. So looking at this, believe me, we can now solve this comfortably using simultaneous method, because we have I1, I2 and what? I1, I2. So we can solve this simultaneously. In order to solve this simultaneously, we see if we can eliminate any of the items. Let's multiply equation 2 by 2. If we do that, for equation 1, we have minus 8I1 minus 9I2 plus 4 equals 0. So that we can now have here, when we multiply equation 2 by 2, we have minus 8I1 plus 2I2 plus 4 equals 0. This is our what? Equation 2. So going further, we can now eliminate. So if we eliminate by subtracting this from this, we have that minus 8I1 minus, this is minus plus. So this becomes 0. Okay, so for this, we're going to have minus 9 minus, this minus plus is minus. So we're going to have minus 11I2 here. Okay, So this is plus 4 minus 4 is 0. So this is 0. So we can now say this is equal to 0. So if you make I2 subject to a formula, you now notice that this becomes 0. This becomes what? 0. So we have that minus 8 plus 8 is 0. Minus 9 minus 2 is minus 11. Okay. 4 minus 4 is 0. So plus 0 here. You have plus 0 here. Everything should what? Equal 0. When we make I2 subject to a formula, we divide both sides. Okay, of course, this is 0. Notice that I2 will become what? 0. So from this, we can see that. So you notice now that I2 here, I2 is 0. The current that passes through this resistor, no current passes through this resistor. And as well, we can see that since there is no current flowing through this 1 ohm resistor, there is no power dissipated by this resistor. And this was the problem, the question I asked you to solve, and put the answer in the comment section. The question was, find the current that passes through this 1 ohm resistor. So no current passes through the 1 ohm resistor. So if you have enjoyed this video, you can subscribe for more updates, for more videos like this. You can invite your friends. We teach both undergraduate students and high level school students. Share the video to your learning colleagues and invite them. You can give it a thumbs up and comment on the areas you would want us to treat next. Thank you so much for watching our videos. Good morning.